Okay.
Alright, vectors basically are the physical quantities which have a size like magnitude and also a direction. So for example, this is your vector AB. A will be considered as the initial point, right from the starting, from where the vector is starting, and then it is moving in this direction. The arrowhead is here, and this point B will be considered as the terminal point. Then another thing which is important for vectors is the head to tail rule. Now head to tail rule is applied whenever we have to add two vectors and we want to see that what is the result of that addition. The result of the addition of vectors is known as the resultant. So in this case, I have shown over here in the diagram that vector AB is given, like the starting point is A and the terminal point is B. So vector AB is added to another vector which is BC. So look at the flow of this vector diagram. This is going in this direction, right?
Yeah.
If you follow this diagram, flow of this diagram, then we would say that the vector will continue and it will come. If we keep on following flow, then it will be like this, right?
Yeah.
But the third vector is always in the opposite direction and it will show the resultant. So I'm not going to put the arrowhead in this direction, but I will change.
Does that say it's always opposite to the flow?
Yes, it is always opposite to the flow of the diagram, right? So I can write now when vectors AB and BC are added, the answer is vector AC. Vector AC. We are not going to write CA, but we are going to write vector AC. So I will add over here that vector AB plus vector BC is equals to vector AC, and AC will be your resultant vector. Now another thing in the vectors are the column vectors. So column vectors are represented by matrices. For example, A is given to you as a column vector as -2 and 3. B is given to you as 6 and 2. And you have to find out A plus 2B, for example. So look what I have written. In place of A, I have written its column vector, -2 and 3, plus 2 times. Why 2 times? Because we are finding out A plus 2B. 2 times the vector 6 and 2. So this will remain as it is, plus now this 2 will multiply first of all with 6 and then with 2. So 2 times 6 is 12 and 2 times 2 is 4. And now we are going to simply add them. Corresponding entries, you get 10 and 7. Okay, this is the way how we are going to do the column vectors. Another thing in vectors is the magnitude of vector. What is the size, how big the vector is. So it means that if a vector AB is given to you as in the form of the coordinates like -2, 3, then we consider x as equals to -2 and y equals to 3, and the formula is x squared plus y squared square root, and these bars, they represent the magnitude of the vector. So we just replace the values over here. In place of x -2 squared, 3 squared, you get 4 plus 9, which is square root 13. So this is the way to find out, method to find out the magnitude of the vector. Now another very easy concept is to see the negative vectors. Negative vectors are basically mathematically we say that they are having the opposite signs, and plus if we change the sign of any vector, it will become its negative vector. And the main thing is the direction. There will be an opposite direction in case of the negative vectors. For example, if vector AB is given to you as 2 and minus 3, then if I want to write down vector BA, I will change its sign. So it becomes minus 2 and positive 3. So in case of the negative vectors,
B.
so yeah,
Okay.
direction is changed, and of course, the signs will be changed as well. If vector AB, this entire vector AB is given to you as 2A plus 3B, for example. This is for the vector A is represented by 2A plus 3B. And for example, there is another point over here, which is, let's say, point C. And a ratio is given. For example, AC ratio CB is given to you as 2 ratio 3, let's say. So this AC is 2 parts, CB given to you over here as 3 parts of the line segment. So in total, what will be the parts of the total AB? It will be
5.
5. So if I want to express AC in terms of A and B, I want to express AC in terms of A and B, I will write down AC is equals to how many parts?
2A plus 3B over 5.
Yeah, this will be 2/5 of the total
times. Okay.
AB. 2/5.
And it's expressed by 2A plus 3B, so you do 2/5 of 2A plus 3B.
Yes. So you write over here 2A plus 3B in place of AB. So AC.
You could also do. Could you also do the 2 outside the bracket and then divide all of it by 5?
Yeah, you can. You can simplify this also. 2 upon 5 multiplied by 2 and 2 upon 5 multiplied by 3B. But mainly, basically, I just wanted to show you that sometimes the ratios are given and how do you convert it into a complete vector form in terms of A and B, whatever the alphabets given over here. Okay? So the question says that this ABCD is a parallelogram. So opposite sides are equal and parallel. So the first thing which we can do over here is to write on the opposite side over here for DC that this will also be 2P, and AD is 3Q, so BC will also be 3Q. Now you have to find out AC. So in this diagram, what we can do, if I can draw this diagram separately, a small one, like this. So this is your A, C, and D. And the arrows over here, originally whatever is given, we draw the arrows according to that. 3Q, and this is 2P. And we are finding out AC. So it is not CA but AC. So AC, put the direction like this, arrowhead. Now which two vectors are added and which one is the resultant vector according to head to tail rule?
The resultant vector is C.
The resultant vector
So
will
DC. AC.
AC will be AC. Very good. So we can write AD, vector AD plus vector DC is equals to the resultant vector, which is equals to AC. Why? Because AC is going against the flow of the diagram. So in place of AD, we simply write down its value, which is 3Q, plus DC is 2P, and you are going to get your vector AC. This is vector AC in terms of P and Q. This is your answer.
Okay, so it's 3 cubes.
So the ratio is given as Bx ratio Xc equals to 2 ratio 1, and X is the point over here, and we are finding out Ax. So can I write like Bx upon Xc is equals to 2 upon 1, because the ratios over here. So Bx has two parts, Xc has one part. So over here, Bx from B to X, there are two parts. And what about Xc? It is
One part.
one part. So the total BC, if I can, conclude from here, it is three parts, 2 plus 1.
And the 3 cubes, so you divide 3 cubed by 3
Yeah.
and you times it by 2 to get that.
Exactly. So if I want to get, for example, let's say Bx, I would say that Bx is 2/3 of the total BC. Bx is 2/3 of the total BC. And what is BC? BC is given to you as 3 cube. It is given in the question. Right? BC is 3 cube. So you cancel out these two, 3 and 3. So we left with 2 cube. And this 2 cube is basically vector Bx in terms of Q. So Bx we have got as 2 cube. Now apply the head to tail rule, means that if I join the point over here, so it is going to give me a small triangle like this. That will be A, B and X. Why we are taking till X? Because we are finding out Ax.
Yeah, I did that as well.
Yeah. So we are finding out Ax. So this will be the direction Ax. AB original direction given over here, which is 2p. And what is Bx? We have already obtained as 2q. Write down 2q over here. So vector AB plus vector Bx is equals to vector Ax. Now put the values, 2p plus what is Bx? 2q, and that will be giving you the answer.
Yeah, 2p plus 2q. Yeah, that's how I got it as well.
Yes. Very good. Okay. Is given to you as 3 and minus 4, for example. And A is also given as the point 0 and 2. So you have to find out the coordinates of the midpoint of AB. So we need to find out the coordinates of B as well. A is given, but we don't have B. So we apply the difference of vectors. So difference of vectors is final minus initial. And final point, basically the terminal point is B. So I'll write OB. Why OB? Because it has to be with reference to with the origin. So O represents the origin. So this is just a notation to write it down. OB minus OA, and this is equals to AB. So what is AB given to you over here? 3 and minus 4 equals to OB, which we are finding out basically, and OA is given to you as 0 and 2. Now you just have to find out OB, so you shift this matrix on the other side. That is 3 minus 4 plus 0 and 2. Why plus? Because there is a minus over here. So when you shift on the other side, it will become plus. So vector OB is equals to 3 plus 0 is 3, minus 4 plus 2 is minus 2. So we have got the coordinates of B, which is 3 comma minus 2. 3 and minus 2. So we have A, which is 0, 2. We have B, which is 3 and minus 2. So this will be your x1, y1 like x1, y1, and this will be your x2, y2. The coordinates of
So
A.
y2 minus y1, x2 minus x1.
The gradient, the midpoint formula is x1 plus x2 upon 2, comma, y1 plus y2 upon 2. So you just have to replace the values over here. Okay?
What?
Is 0 plus 3 upon 2 and 2 minus 2 upon 2. So you'll be getting 3 upon 2 and 0.
Zero